So we are dealing with the sixth problem in this series. The problem number is 1.124 and the problem is stating a chain of mass m equal to 0.80 kg and length 1.5 meter rests on a rough surface table so that one of its end hangs over the edge. The chain starts sliding off the table provided the overhanging part equals 1/3 of the chain length. What will be the total work performed by the friction forces acting on the chain by the moment it slides completely off the table? So if we approach this problem, so let us first of all draw a arrangement of the situation which the problem is explaining. So we have a table edge. So let us consider a table edge like this, and on top of this table one portion of chain is there and the other portion of the chain is hanging from the table. So according to the problem, the 1/3 length of the table is hanging, and hence I can say that the hanging part is having mass mg/3 and the resting part is having mass 2mg/3. The length of this part is 2l/3 and the length of this portion is l/3. So now the first thing that we do is we calculate the average value of coefficient of friction. So the problem is stating that when 1/3 of the chain is hanging, then the chain starts sliding off the table. So अपने लिखते हैं as sliding impends at l/3 of hanging part, then mu times of 2mg/3 must be equal to mg/3, and on solving from here we get mu equal to half. So this is the value of coefficient of friction which the table chain system is providing. Now we need to calculate what will be the total work performed by the frictional forces acting on the chain by the moment it slides completely off the table. So to start this part, now what we do is we again construct this edge of the table. So what we can say is that if we consider a section of the chain at a distance x from the edge having mass dm. So over here we can write that lambda equals mass per unit length equals dm/dx. So therefore dm, or the small portion of the mass, can be written as m/l dx, or x length of the chain, x length of chain will weigh mx/l, and using this weight we can calculate the value of frictional force. Therefore frictional force offered by this portion is equal to mxg/l times mu. So this is the value of frictional force which it offers. Now since this chain is undergoing a displacement x, and at every point of time we can calculate the work done is equal to integration of f dx, where the value of x is changing from 0 to 2l/3. So therefore work done by frictional force equals mg mu by L integration x dx 0 to L by 3. So we solve this value to obtain L square by 2, 4L square by 9 by 2. So this is the aspect that we have. So on solving we obtain the value as, so mg mu can be written as half, 4 will cancel out, L by 9. And now since it is work done by frictional force, so we are putting a negative sign over here. So if we substitute the rest of the value, then we get work done by frictional force as 1 by 9 times of mass of the chain 0.8, taking value of G as 9.81 and length as 1.5. So we calculate that the work done by frictional force is minus 1.3 joule. So this is the answer for the problem which we have discussed here.